Hello guys, my name is Arun Tyagi and today we are going to discuss a low-level design. We are starting with a chess game low-level design. This is very frequently asked design question. So we will cover it from the perspective of, we will try to give it a structure that if you are in a low-level design interview, then how you should approach it, and then ultimately obviously it will go in the direction where your interviewer want it to go, right? So let's just try to establish a structure first. So first thing first is we always write down the requirements, and in low level design normally we don't care about non-functional requirements. We always focus on, emphasis is always on the functional requirement, what it actually doing, right? So I tried to write down the low level requirements of chess design here. So these are straightforward. User should be able to log in or sign up. User should be able to app rather should be able to match two online users who requested for a match so that game can be started. Then app should create a game for those users. App should assign a color to the users. App should initiate the chessboard. User should be able to move a chess piece from one cell to another cell, right? Game should check, is this a valid move or not? Game should check if state of the what is the state of the board. Game should announce a winner, or and stop the game whenever a winner is there. Game should continue until one user is a winner. User should be forced to follow all chess rules, right? These are the requirements, and it has nothing to do with a low level designing thing. It is just your knowledge of the game. So these you can write down with the help of your interviewer also, and normally you will always be knowing about the thing when they are asking you the low level designs. Once this is done, right, the next step you can do is try to list down all the proper nouns from these statements. Like in first one we have user, right? In second one we have app, right? And a winner, likewise. So just list down all the proper nouns from these statements. So here are the nouns which I got it from my requirements. Once this is done, so I'm just trying to create a structure how to approach, so that in interview actually you will have a content to present. And when you have the content, then your interview is always having the details, that you know the details, and then it always depends on your knowledge of the basics, right? So once this is listed down, then what we can do is we will just try to cluster, and we will try to omit some of the things which are not like the noun, and that can be one property of another noun, right? So I tried to do the clustering here. Like for example, user and player are similar things. By similar I mean player is a user, right? Then my game, my board, cell, and piece, these things go together. This can be an association if I talk about object oriented programming, but just think of that these things go together, just write them together, right? And then app is kind of an independent entity. So I tried to do the clustering same way you should do the clustering of all the nouns you are having, right? Once this is done, so this is also your what you can say, class identification, that these classes should be there in your design. That is what we did when we listed down all the proper nouns. Next thing we can do is we will try to create an activity diagram, which is a very simple diagram. The only thing we are having is here who all are actors here. One is user or player, you can say, and second is app. All others are not actors, right? Game is not an actor, board is not an actor, cell is not an actor, piece is not an actor. Only these two are actors who are acting, right? And they are acting upon these things. So just try to list down what these two actors can do. Like user can log in, User can request a game, and user, whenever its turn is there, he can move a piece from one box to another, right? So these are some of the activities this user can do. And you can also specify like user who is a player can only move, right? So user can log in, user can request a game, but a player will move, right? So this is this. Then what app can do? App can initiate a game, but app can only initiate a game when somebody requested it. So these two activities are actually linked, so this activity depends on this, right? Then what app can do? App can add users into a game. App can print the board state, and app can declare a winner. So likewise, just try to list down the activities of your actors, right? So far we are good. All right, let's move to the next step. So before we move to the next step, just check this clustering again. What we did is we wrote down things which are should be together. We wrote down them like this, right? So now I'm moving to the next step. Next step is nothing but the UML diagram or class diagram, we say, right? And this is not something very theoretical, or there's no rocket science behind it. So if you remember the clustering which we did in just the last step, we wrote down user, player together. We wrote down game, board, piece, and cell together, and then app was separate, right? So here also we did the same thing. We just wrote them down together. Then we define the relationship. Player is a user, right? There is a relationship between them. So we just did this, that player will inherit from the user class. Then game will have a board, so game has a board. Then board will have multiple cells, so we just did that board having cells. Then cell will have a piece or can be empty, right? So has a cell, so you can say one cell, one piece, so one-to-one relationship is there. And then app will have users, app will have games, games into it. So that's it. Then finally, piece will have multiple instances of it. Piece is, you can say, an abstract class which will have instance like queen, knight, and others. So we did that. Then we will try to write down the basic properties and basic functionalities we can think of for these classes, right? And we already created the activity diagram in the last step, so we will use that diagram to write down the functionalities. So user will have basic properties like the name and the level, whether you are a pro level user, or you are intermediary, or a beginner in the chess, at least on that app, right? Then what a user can do, as per our activity diagram, user can log in and can request for a game. Then player is actually having a color and how much time it spent on the game so far, because sometimes games are time bounded, that you only have 10 minutes to move all the to do all the moves into your game. Then finally, you can move, so move is a functionality. Then what game is having, game is actually having a board, and game is having two players, right? So we wrote them down here. Then then board is having cells, which is a matrix, right? So and then cell will have a piece, right? So cell is having a piece. And then a piece will have these different instances, and every instance will give their own definition of if whether this is a valid move or not. So is valid move in piece is an abstract function, but is valid move in a concrete class, this is where the definition will be. And if you see, this is nothing but a command pattern, when every concrete class is giving their functionalities, providing their functionalities when it is getting executed on the runtime. So this is your basic UML diagram done, right? Now let's move to the next step. All right. So far, Okay, so we just discussed about how we can create a UML diagram, and so far whatever we did should not be a time taking process, right? Once you are done with this one, this step will lead us to the next step. Now in next step, what we will do is we will just write these classes blindly, and we'll create these properties and these functions like skeleton functions, which need not to have any definition inside them, but just write the skeleton of it. So I have created a fast skeleton of all of these. So if you see, I have created a user class which is having ID, name, and level, which we have shown in the UML diagram, and these two functions which are empty. Same way, from this diagram I have created all the classes into my I'm calling it a skeleton, so I can go one by one. User we have seen, then we have player, which is inheriting from user, and additional properties into player are color and the timestamp, as we saw. And then move is the action it is having. This is again an empty one we have created. Then go towards the game. So we have a game class with all the properties we have shown, that it has player, the board. Then let's go to the board. Board is having nothing but cells, right? And then if we go to cells, cells is having nothing but the piece, whether it is having it or not having it. So it can be null or not null, right? And also the address of this particular cell. Then moving to the piece itself. So in piece we are having what is the color of it, what is whether it is in game or not, though we don't need this property. I'll remove it from the real code which we'll write after this. And whether this is a valid move. Like I said, this is a abstract function, and every concrete instance, concrete class of this type will need to write the definition of it. Yeah, they need to provide it. For example, let's move to this one. So this is inheriting from piece, and what we are having is and skeleton again, but the function it needs to override, right? So this is our skeleton done. Again, this also should not take a lot of time, right? This is just a skeleton which we have copy pasted everything from the UML diagram we created in the last step. Now next step is, so our skeleton code is ready. Now next thing is we should complete the functionalities of all the classes. Once the functionalities of all the classes is finished, so end to end, the chess game will run. So now here there can be two approaches. One is top down. In top down you can start with a class like app, which is running, which is using the user app, using the game app, right? And then game is using the boards, and likewise. So top down. So if you will give the definition of this, then you will know what definition of game you need to write. When you will write the game, then you will know what you need to write for the board, and that's how you can approach it. Another approach can be start with the bottom up, right? What is the most the concrete class which you are having, which is independent, which is not using anything else but is being used in other classes, right? So you have to pick one, and whichever you will pick, both will lead you to the solution. So and also, because this is interview, it normally depends on, maybe interviewer want to focus on how you will write the algorithm, how game will run end to end, right? So that normally depends on that. But here, for discussion to take it forward, we'll start with the bottom up approach, where we will think of what to write in the knight class and queen class and other pieces which we are having. Okay, so I'll start with the bottom up. So first we'll start with this. So we have a pawn class, and in this one, in skeleton, we defined, so I created skeleton folder separately just to differentiate both. We defined empty methods, we had a constructor, and is valid move, right? Now we try to write the definition of it. In constructor, I just instantiated it, right? Name, short name, and all. Short name we will use to print it here on the console, because ultimately we'll run this solution on the console. We do not have a UI, right? So is valid move, we'll try to complete. This is simple is valid move for this kind of a piece, right? So normally how we do, uh, basically it should, this piece should move forward, right? First thing. So if you are black and so in a board, we are imagining that black is on the top and white is at the bottom. So black should move like this and white should move like this. So we'll just check if you are black and you are coming down. So we are just checking the direction, if they're moving in the right direction or not. Otherwise simply return false, that this is not a valid move. Then you are check if you are moving diagonally, then there should be an opponent in the diagonal box, right? Then it's a valid move. Otherwise you cannot move diagonally, right? So here we are simply checking that in diagonal positions, if you move there, then whether there was an opponent or not, right? Finally, if wherever you are targeting, if you're going forward in the straight line and there is nothing in that box, then it's fine. But if there is something, even whether it's your piece or opponent's piece, then also you cannot move forward, right? So that's simple condition we wrote. So whatever conditions we know about this kind of piece, we just try to write that down here. We put all the ifs, that what is invalid for it. If everything is passed, there's no invalid move, then return true, that yes, it's a valid move. Let's just check the same thing for if we have created any other class. So I have not, right? So likewise we can write for every piece. Now we can in bottom of approach, now we can move to the parent class of it. So piece is basically your base class, and in this we are actually not having any functionality. So we have an abstract method, like we said in your command pattern, you simply gave an abstract method and every concrete class defined it, like we have seen here. So pawn class defined gave the definition of it, concrete definition of it, and here you are having an abstract function. So this is your base class, right? Now we can move to the next one. So as per this, we defined these here. For example, I only defined this, but you can imagine that we defined all of them, and it's again depends on the interviewer which class definition he wants you to write, right? So we completed this because this was very straightforward. Then let's move to the cell one, which is using the piece. So cell also is very straightforward, that you are having a piece into it, and by default that piece can be null, right? And you are having position of it, where that cell is, right? Then we can move further up into this. So we will define a board. So from here also we'll see the board was nothing but, just it is just having collection of cells, right? So if I move to board here, yeah, so this was a collection of cells, and what extra thing I added here now is, first is instantiation of it. When a game is being created, then it is having a function to actually instantiate the board, right? So here we created this to place all the pieces at the right place in the starting position. So this will be called by the game class itself. So this is very basic, that from your on the in a matrix, in the top row you will have one side of pieces, and in the bottom row you will have another side of pieces. So by default every cell is empty, but it is having a position, right? Empty means it is not having a piece, so by default the piece is null, right? But then for white and black, you place the things in that particular row for 1 and 6 row, right? Because right now I'm only placing one kind of a piece because I gave the definition of it, right? Same way you can place more and you can give the definition here. The second thing I did, because I have to run it here in the local on the console, so print the state of the board on console whenever I want to, right? So I just gave this, which will do nothing but print that matrix, and it will simply show which piece is where right now. And when I will run it, then you will see the how it is printing the matrix. All right, so we have covered the board. Now uh, before we move to the game class, right, I think we should check the player class, because game is using board and player also. So board we have covered, let's move to the player class. So in player class, first is obviously the properties which we are having. What is the color, right? Whether you are a black or white player. Then the time spent in the game, because some games are like time checked, that you have only 10 minutes to complete your moves basically. So that's why this, and that's it, right? Then one function which we had in our player was move. That player can move one piece from one cell to another, right? So we'll complete this function. This is again straightforward. First we are checking whether this is an invalid input in itself. By invalid input we mean, right, if there is no piece from, because you are passing the input like move from this to this. If there is nothing in from, that means this is an invalid input. Again, if you are trying to move opponent's piece, right, again, so that is again another invalid input. Now even if your input is valid but the move is wrong, right, if destination contains your piece only, if you are trying to move knight from a cell to another cell and that destination cell is containing your piece itself, then also you cannot move. Then if the move is not valid as per the is valid functionality of that particular piece, so you will check with the piece. So you already got the piece from your source cell, that what piece was there, and then you will check the move which user is trying to do, whether it was valid or not. Pawn can only move straight, knight can move in one fashion, right, king can move another fashion, likewise. So you will simply check. So if that returns false or true, on that basis you will take this decision. Finally, whether you are killing an opponent in this move or not. If you are moving, if your move is valid, means so far you reached till here, there was no return false, that means your move is valid, but destination was containing something, that means you are killing that opponent's piece, right? In that case we will mark that as to be killed, and that cell will be empty, and ultimately you will place your piece from your source cell to your destination cell, right? So this is one function which looks lengthy, but it is very straightforward algorithm, right? Or you can say steps of some if checks into that. Then another function which we need to implement here is whether user can move further or not, and that can be checked on basis of whether your king can be moved or not, right? So what is the position of the board at that time, right? So this I have not completed yet, but this will be again some checks which you have to do. Now after we covered the player class, now we'll move to the game class, which is using the player and the board class. Let's complete the definition of our functions. So basic properties were there. Game is having ID, it is having a board, and it is having actually two players, not one player. And in this intermediary variable I'm using to put whose turn is this, the current player who need to take the. Then this is basic constructor. Then the main function I'm having here is basically the start, which is where the game is getting completed. So in this one, this is actually a, you can say, end-to-end algorithm to run the chess game. So it will first initiate the board, which we have seen in the board class, where it is placing all the pieces on their initial state. Then this will run until there is a winner or somebody leaving the game in between, right? So there can be multiple conditions. So but uh, the, from the perspective of this game, this is running infinitely until someone from inside will break it. Then first thing we are doing is printing the board. This is for to show the user what is the current state. Then we are saying that it's whose turn is this. So we are printing the color, that white turn or black turn, right? Then whoever turns it is, we are asking them to input their move on the console, because we made we are using console here to run this design end to end. When user will provide their input on the console, so we are only asking them from which cell to which cell you want to move, because we already know on which cell what piece is there, so we need not to ask user what piece he is talking about, right? Then we are just checking if user can move that, right? So if that is an invalid case or invalid move or invalid input, on all those cases it will check here, and it will simply ask user to provide a valid move until they are providing the invalid moves. So this will happen whenever a valid move is provided. So this move function itself, which we just checked, will actually move the piece from one cell to another, right? Then we are giving turn to the another player, right? Once turn is given, then we will check whoever turn it is now, will he be able to move in the next turn? Means if there is checkmate, so we had a can move function which we didn't complete yet, so we can complete, but that function is responsible to return whether this user can move or not, right? If he already lost, if he cannot move, then just announce the other player as winner. If he can move, then the loop will continue. So this is straightforward end-to-end algorithm of the backbone of chess, because all the subclasses, or you can say independent classes, are doing their responsibilities, and this is just leveraging their definition to run this backbone algorithm. So now we covered all the main classes of this design. Let's cover our final class, which is your app is actually to run the game end to end. So whenever this program will give the control to the app, and that we can see from program class, which is the user of this design, right? So that is simply creating the object of the app, um, and then simply saying just app.start. So as soon as control is coming to this start, what it is doing is, first it will ask user to whether you want to start the game or not. As soon as user will say yes, I want to start the game, you will what you will do is you will simply do a create new game. Create new game is nothing but ask game to user to provide their names first, then assign them the color, who is white and who is black, then finally initiate the game, right? The class which we just used, and call the start function, the start method which we just saw. At the end of the start method, either user will exit from the game, or either you will have a winner. When you have a winner, just announce the winner. As simple as this, right? This is straightforward. Now let's run this to see how it will how exactly this design is looking right now, whether it is working or not, right? All right. To run it, because I'm using C#, so I'll use the .NET Run. It is asking me to start game. Yes. Then it is asking username. I will simply give player 1 P1 and P2, right? Now when it is given, then it is telling me that it's color white turn, right? So if you see, because I have in places only pawn for now on the board, so if you see, every other cell is empty, and in this row we have white pawn, in this row we have black one, right? So for white one, we will try to provide a valid input. I want this guy to move, so which is like my first row, first column. I want to move this to second row, same column, right? So if you see now, these two are empty, it moved here, right? Now it is saying black turn, so I will try to move this. So I will say sixth row, second column, or first column, let's move the same one, and I want to move it to fifth row and second column. I'm trying to do diagonal, which is invalid. So this is invalid. I have to provide a valid input. So I'll say sixth one, I want to move to fifth one. Yeah, if you see now, this guy was one step ahead, and same thing, this guy is now one step ahead. So that is how it is running. So same thing we can now extend for every piece. So you just need to define all the pieces, you have to place them when you are initiating the board, and that's it. This should do end to end for the chess. So this is the basic design of chess, and what we actually covered here is we tried to give a structure that how can we approach the interview so that we have lots of content to create in the interview rather than having a very least content, right? That's it. Thank you very much. Bye bye.